keep dividing by our exponents. When I go to 2 to the negative second power, I'm dividing by 2 once again. 1/2 of 1/2 is 1/4. The same thing happens when we change our base as well. So if I look at the base is 10, 10 to the 4th power, 10,000. 10 to the 3rd power, 1,000. 10 to the 2nd power, or 10 squared, is 100. 10 to the 1st power is 10. As we keep going down, we're going to keep dividing by that base, which is 10. So 10 to the 0th power, I divide by 10 once again. 10 to the 0th power is 1. 10 to the negative 1st power, I divide by 10 again. 1 divided by 10 gives me 1/10. And then one last time, if I divide 1/10 by 10 again, I'll have 1/100. So everything is pretty normal until we get to the 0th power. Anything to the 0th power is 1. And then from there, the pattern that we are seeing is that we are going to keep dividing by that base over and over again. So if I take a look at something like 2 to the negative second, that's like 1/2 squared, or 1/4. 1/2 times 2, something like that. So here's our 3 rules for today that we're learning. For any non-zero number, so let's say it's x, x to the 0th power is 1. Anything to the 0th power is 1. Can you please put your desk on the ground? For any non-zero number x, if I have x to a negative exponent, doesn't matter what that negative exponent is, just that it's negative, I'm going to rewrite it as 1/x to whatever that exponent is. Because once I start going negative, it's like division instead of multiplication. That rule also is going to apply backwards. So let's say I have a fraction already, and in that fraction, in the denominator of my fraction, I have a negative exponent. Well, if a negative exponent brings it to the denominator when it's in the top, a negative exponent in the denominator is going to do the opposite. It's going to bring it up to the top. So we could rewrite this as x to the n over 1. So that negative exponent, essentially what it's doing is it's going to flip it either from the top into the bottom or from the bottom into the top. Let me show you more what that looks like. Oh, let's review our rules. Remember I told you these 4 rules yesterday? They're still going to apply today, especially the first 2 of them. We are going to see those more today. Number 1 is there are no negative exponents. So we should not leave any of those negative exponents. We are going to do this trick with them to move them either from the top into the bottom or from the bottom into the top. And there are no exponents equal to 0. So if I have x to the 0th power, I want to switch that into a 1. We're always doing multiplication in these, so if I switch that into a 1, it's just kind of going to disappear. It's going to be invisible. We don't have to write it. So x to the 0th power just kind of cancels out. The other 2 rules that we talked about yesterday, there are no numbers raised to exponents. So I'm not going to leave anything as like 3 squared. I should simplify that to 9. And each base is written once. So I should only have 1 x in my problem. I should only have 1 y in my problem. I shouldn't have multiples. Good? Let's look at the examples. All right, so when I see a negative exponent, I'm not talking about the base being negative. I'm talking about the exponent itself being negative. I'm going to highlight it, and that tells me that it's got to move. So if it is just written as like a whole number raised to an exponent, we're imagining that that is in the numerator of a fraction. So a -3 exponent in the top is going to move this whole thing down to the bottom. So I will write that as 1/4 to the positive 3rd power. Our goal here is to get rid of the negative exponent, so when we move it, we make that exponent positive. Does that make sense? Remember our rule that we don't leave anything, a number raised to an exponent. So I'm going to take that 4 to the third, and I'm going to multiply 4 times 4 times 4 to get 64. This is 1 over 64. Does that make sense? Same thing in example 2. We're imagining that this is like 3 to the negative second over 1. I see that negative exponent, and to get rid of it, I move the entire thing down to the bottom. So this is 1 over 3 to the positive second, or 1 over 9. Things get a little bit more tricky when we start talking about negative numbers raised to negative exponents. What we have to notice when we're talking about exponents all of the time is that I have in parentheses, that whole thing is raised to the power. So the power goes to everything inside of those parentheses, what is directly next to it. So that entire negative 2 is going to go into the bottom, 1 over negative 2 to the positive 4th power. Now, 2 to the 4th power is 16. Do we think this is going to be a positive 16 or a negative 16 because of that negative in the front? What do we think? James? Should be a positive. So my rule, I'm going to write it up here for us. When negative numbers raised to exponents, are you writing this down? Yeah?
Yeah. No. Yes, I am.
Here's our rule. If my exponent is a odd number, so 1, 3, 5, 7, etc., I'm going to get a positive answer when I simplify that. So negative 2 to the 3rd power would get me a negative 8. If I have an even exponent, I'm going to get, oh, sorry, I did that backwards. This is supposed to be a negative. I just wrote it backwards. There we go. That's fixed. So a negative 2 raised to the 4th power is going to get me a positive 16 because that 4 is an even number. If it was negative 2 raised to the 3rd power, we would get a negative. So in example 4, one thing that I see in example 4, do I have a negative exponent? I do not have a negative exponent in example 4, so I don't have to bring it down to the bottom. All I have to do in example 4 is raise negative 3 to the 3rd power. Negative 3 to the 3rd power is going to be a 27. Is that 27 positive or negative? That time it's negative because this is an odd number. This one was positive because this is even. Good? The other rule we're learning about today is things raised to the 0th power. So 3 to the 0th power is what? 0. Nope. 0. Negative 2 to the 0th power is? 1. What is the difference between these two examples in the middle here? They both have negatives. What's the difference between them? James? In example 6, there's parentheses around this whole thing, which means the entire thing becomes 1. In example 7, there is no parentheses around that negative 9, so the 0th power is only talking about this part. The negative is not affected. 9 to the 0th power becomes 1. My answer is negative 1. So what about example 8? Positive 1 or negative 1? That's going to be a negative 1 as well. Questions on that? I'm going to make it more tricky now. We're going to look at the examples that have the variables in it. Our rules are not going to change. Our two rules are still exactly the same. So when I have x to the negative 9th power, that exponent is going to bring my x, which is currently in the top of this fraction, down to the bottom. So this will be rewritten as 1 over x to the positive 9th. Good? As I start adding in variables, we're going to have different bases to work with. So in example 10, how many unique bases do we see here? Do you remember what a base is? There's two bases. There's an m and there's a 3. 3 is raised to what power here? We can't see it. It's a 1. So that's a positive number. We don't have to change anything about that. But the m is raised to the negative second power. So that I am going to highlight, and we do need to do something with that. If it's in the bottom already, and it's negative exponent, it's going to go to the top. So the negative 3 to the first power, that stays where it is. But the m to the positive second is going to go right up next to it. Technically, when we move that m to the second up to the top, it's leaving just a 1 in the denominator. We do not have to write the 1 in the denominator. It's implied. So that's there. In example 11, there are 3 bases. I see 4 to the positive 1 power, c to the negative third, b to the positive 1. The only one with a negative exponent is that c to the negative third. Oh, hello. So that's the only one that needs to move. The 4 and the b are going to stay exactly where they are, and that c to the negative third will go to the bottom and be c to the positive third. What do we think happens in example 12? I heard somebody just whisper it. What did you whisper? Say what? They're going to switch spots. The negative 3 at the top, the x to the negative 3, is going to bring this x down to the bottom, and the y to the negative 7th is going to bring that up to the top. So they're going to switch spots. So the 2 stays where it is. That had a positive 1 power. The y to the 7th goes to the top, and the x to the negative third becomes x to the positive third in the bottom. Beautiful. Any questions on that? I got a couple more examples and we're done. What happens here? What does this look like? If you know what it is, just raise your hand and tell me what the answer is going to look like. Jaden? How do you write it? Just all together like that? What do we need to do with this? Yeah, Sarah? Yeah, it goes 1 over m to the second, n to the fifth. This n to the fifth has to go down to the bottom. When we move that n to the negative fifth down to the bottom, we're leaving a 1 up there because there's nothing else left up there, so we write a 1, like a placeholder. Good? No? Yes? No? We're shaking our head. If I take that n to the fifth out of the top, there's nothing left there except for an invisible 1 that we can't see. So we write it as 1 over m to the second, n to the fifth. Okay? Okay, there's a lot going on in example 14. What is one thing that we know we can simplify? Jaden. That's going to go to the bottom. Everything else can kind of stay in the top, right? Negative 6, x to the third, y to the 0th, z to the 5th goes down to the bottom. What else can we simplify in here? Y to the 0th power is going to kind of just go away. Y to the 0th power is 1. Maybe I should make that look more like a 1. This becomes 1, and it's kind of just going to go invisible. It's going to disappear. I no longer have to write it. So this is going to look like, oh gosh, my final answer, negative 6 x to the third over z to the 5th. Do we see how we got that? What about example 15? A lot of steps going on in this one too. What do I need to take care of? What do we see? What can I take care of? Sarah?
You do w to the 5th power.
We're on 15, not 16 yet. Hold on.
7a0 to the 0 power, and then you do c to the third power and d to the fifth power over b to the first power.
Perfect. So Sarah said, I see these. I'm going to move that b to the negative first down to the bottom. I'm going to move the d to the negative fifth up to the top. And everything else kind of stays where it is. So c to the third, d to the fifth goes up there with it. And then over b to the first. B to the first, that's another kind of invisible one that you don't have to write in there if you don't want to. What else can we finish this off with? Autumn? A to the 0th power becomes 1, so I don't have to write it anymore. This is 7, c to the third, d to the fifth, all over b. Perfect. One more. What happens in 16? I only got one step in this one. That one's nice and easy. What one step do I need? Jaden?
You just move the z to the negative third up.
Perfect. W to the fifth stays where it is. Z to the third comes up and joins it. 8 stays in the bottom. Any questions on this?